Hello everyone, it is Godot time. Some time ago I already published a video on how to create grass with Godot, but a lot has changed since then. Godot 4 has been released, I created my own plugin to help distribute the grass across the landscape, it's called Yamms, yet another multimesh scatter, and I just started this video channel in English to reach viewers all around the world. So I thought it's a good idea to bring this topic up again in a brand new version. So let's get into it. At first we need a picture of a tuft of grass. This is done in Gimp. Draw a single blade of grass on a transparent background. Then copy and paste the grass blade a lot of times with variations in size and angle. Do it until it looks like this. Some grass blades are mirrored, some are broken, and some are bent. Now the image needs to be exported to be used in Godot. Here we have to be very careful how we export the image. Of course we could export it just as an PNG or JPEG file. Godot does accept these images. But when we add the grass to our scene, we run into some issues with these image files. Here we see an early image of my project which shows what's going to happen. The plants in the background are rendered in front of the grass which is behind the plant. So what's going on here? Well, let me explain. The grass is far away from the player character and the camera. That means that the grass object and the texture is rendered very small. So Godot scales down the texture automatically. The texture contains many transparent areas between the grass blades. Let's scale the view down in Gimp. That's what Godot does as well. To better see the result, I take a screenshot of this view and scale it up again. And there it is. A blurry mess which is half transparent. So everything behind this texture can be seen through the grass. So what can we do about it? Well, that's easy. Let's pre-calculate these scaled down images. First, make sure that the image size, the width and the height are the same number. The numbers must be a power of 2, so 1024 or 2048 or any other power of 2 will do the trick. Next, we export the image. Click File, Export As. Type any name you want. Make sure the option Select File Type by extension is selected and type the extension DDS. Hit the Export button. Yes, I want to replace the file. Select the option to generate the mipmaps. Select the mipmap filter to nearest and the wrap mode to clamp and hit the export button again. Now the image will be saved and exported as DDS file. If you now open the exported file, File Open, Grass DDS, and load the mipmaps, then you will notice that there are several hidden layers for each mipmap level with different resolutions. So if you make them visible, you see that they are getting smaller and smaller. And if you scale it up a bit, then you will see that there are some transparent areas between the grass blades, but no half transparent area. Yes, this looks a lot like good old pixel art, but this prevents objects behind the grass to be seen through the grass. And so, let's have a look at the screenshot of my old project. The plants in the background are hidden by the grass, as it should be. Now that we have a decent looking grass texture, we need a good 3D mesh to be placed in Godot as a tuft of grass. This is done in Blender, so here I have a new scene, and let's get rid of the default cube. Next, add a new plane to the scene and rotate it so that its direction is upright. In edit mode, move all vertices upwards so that the bottom line of the plane is on the word origin, but the pivot point, the little orange dot here, still is on the word origin as well. Scale down the plane a little bit. It doesn't need to be 2 meters high, it's just grass. And now we have a first simple mesh and we can put the texture on it. So just click on the material button and add a new material slot. Click on the new button to create a new material, and here it is. Rename it just grass and change to the shading view. Blender already shows some default nodes, principal BSDF and material output. We leave them and we use them. We just add some more nodes. So click Add, Search, and type in Image and choose the node Image Texture and put it left to the principal BSDF. Connect the output color of the image texture to the base color of the principal BSDF. In the node image texture, click the button Open and select the previously exported grass DDS file. As you can see, the grass texture now is projected on the plane. It's not pointing into the right direction. I need to rotate it by 90 degrees, and the background is not yet transparent. But we'll fix these issues. To get the background transparent, I connect the alpha channel of the image texture with the alpha channel of the principal BSDF node. So I just connect these and I'm done. So still the background is not shown as a transparent background. I need to modify the material settings. So I click on the material button again, open the slider for settings and change the blend mode from opaque to alpha clip. And now the background is transparent. Next, I change the orientation of the image on the plane. So I just switch to the view UV editing. And here on the right side, I see a preview of my object. Well, let's see the texture on it. So here we go. And on the left side, I see the texture image with the UV mapping. So I select all vertices, click the R button to rotate, and rotate the image so that it is upright and the way it should be. Yeah, great. Here we already have some nice looking grass, but if you look at it from the side, we do not see anything because the plane is just two-dimensional and we cannot see it from this way. So I change to the top view, hit the key 7, then I change into the edit mode by hitting the tab key, and now I am able to see the plane, which is just a line because I'm looking from the top onto the plane. So with all vertices selected, hit the A button to select all vertices. I duplicate the plane and rotate it to make it from other directions visible as well. So I hit the button Shift and D for duplicating, the R key to rotate the object, and the Control key to lock the rotation. And now I can rotate it by, let's say, 45 degrees and click the mouse button to place the new plane. I repeat the step again, Shift D for duplicating, R for rotation, Control to lock the rotation. And once again. So now it looks like a star and I have several planes with the grass, and now I can look from any direction and the grass is looking great. In any case, the problem still persists when I look at the object vertically. So to get rid of this problem, I tilt each plane a little bit. Let's get into the top view again and change to the edge selection mode, and now I can select the top edge of each plane, hit the G button to move it a bit and move it a bit sideways. Do this with all planes. And then it should look like this. If I now look at the grass from the top, I still see some grass. At this moment we are already done with the modeling part in Blender. We just need to export the object and can use it in Godot. So let's change back to the object mode, select the plane, okay, rename it, it's grass. So select the grass object and hit File, Export, and choose the file type wavefront object. Name the file as you wish. I leave it as it is. Important is to select the option Limit to Selected Only and hit the Export button. And now everything is done to be imported in Godot. So here it is. I started Godot and I already prepared a little example scene with the terrain, which is just a mesh that I created before in Blender and added a collision shape to it. First, we want to import the grass object into the project's file system. So here on the left side, we see the file system of the project, and there I created a subdirectory meshes nature. That's the place where I want to drop the grass object. To import the object, I just need to drag and drop from the Windows file system the exported object file. Here it is, grass object, and I drag and drop it into the directory where I want to place it. So once this is done, here it is, there is the grass object. Next, we do the same with the image texture of the grass that we created in the beginning of this video. That needs to be imported in Godot as well. So I created another subdirectory. Here it is, materials, nature. That's the place where I want to drop the material and the texture. And so I just need to drag and drop the image texture to this directory. Now let's see the grass object in action. In your scene, just select the node which should contain the grass object and drag and drop the grass object into your scene. As you can see, the grass object has been created underneath the selected node in the scene tree, and this object will be regarded as a reference object so that we can work on the material. But later we are going to delete this object because we want to spread thousands of grass instances in the scenery without having thousands of objects in your scene tree. Okay, then let's work on the material to make it look better. So in the file system of your project, right-click the directory that contains the grass texture and create new resource. A dialog window shows up and we can select the resource that we want to create. We want to create a shader material. Type in the name for the material, let's say grass, and save the new material. So why did I choose the shader material instead of the standard material 3D? That's easy to explain. The grass should be animated. It is supposed to move slowly in the wind, and this is not done by an animation. Later we have thousands of grass objects in the scene, and we cannot animate each one separately. Instead, the shader takes care of it, and it is done for all grass instances. Alright then, now I assign the new created material to the grass object. So I select the grass object, open the category surface material override, and drag and drop the new created material to the slot. Here it is. We do not see any changes because there's no shader in the new material, and so the whole object still appears white. But now we can work on the material and the changes will be visible at the grass object. Because the material is a shader material, it requires a shader. So let's create one. Select the material, and in the shader slot it shows empty. Click on it and select the option New Shader. And of course we want to save the shader in the same directory where the material and the texture is located. And the dialog already suggests the correct directory and the correct shader name, so I just hit the Create button. And there is the shader. Now double-click the created shader file, and the editor opens where we can implement the shader. The shader already includes some initial code. The shader type is set to spatial, which is the default shader type for 3D rendering. so we leave it as it is. The shader also includes a function fragment, which draws every single pixel of the texture onto the object. Right now this function is empty, so the shader doesn't do anything at all. And that's what we see here. We just see the white object without any texture. Okay, then let's put in the grass texture into the shader material. So we need a uniform sampler 2D. That's the image texture that we can put into the shader. Let's give it a name. Let's say plant texture. And we want to use it as a source for our color. So source color. And don't forget the semicolon. The keyword uniform here means that this field is exported to the Godot editor. That means now we can assign any texture to this shader. And after we edit this line, it should work already. So double click on the grass material. Here you will find the slot for the shader parameters. Open it, and here you will find the plant texture. That's the field we added here. And it's empty. So now you can drag and drop the grass DDS file just into the slot, and there it is. Great. But the material didn't change at all. Here we still see the empty material, and the grass object in the scene didn't change either. So what's wrong? Yes, we added the plant texture, but we don't do anything with it. We do not project it onto the object yet. So let's change it. First we need a vector with 4 values, vec4, and name it color. So what is this vector all about? It is an object with 4 numbers, and the color is coded in 4 numbers. It's red, green, and blue because we are using RGB colors, and A for the alpha channel, the transparency channel. Now let's assign the color from the texture to this vector. So equals texture. That's a function that retrieves the color from the texture. So we pass the plant texture to this function. And then we need to pass the information how this texture should be projected onto the object. This information is provided by the object. Remember, we've done the UV mapping for the object, so it is already there. And the object passes this information to the shader, and it's in the parameter UV. So we just need to pass the UV parameter. This returns the color of each pixel of the texture. We want to use it as an RGBA color, so let's call RGBA. Now we have the color of the texture, so all we need to do now is to give out some output. That should be very easy because the shader already provides some variables, and we just need to assign the color to this variable. So the variable is called albedo. That's the variable for the color. So albedo equals color, but albedo is a 3-dimensional vector, and we are supposed to pass the RGB color only, but our color vector is 4-dimensional. So just pass the RGB color to it. And now the material changes and the grass texture is projected on the object. Still no transparency because we ignored the alpha channel right now, but this will be done soon. Okay, let's have a closer look at the grass object. And as we can see, we cannot see the backside of a face. This absolutely makes sense because usually objects are a little bit larger and we can see the outside faces of the object only. But the grass is made of planes. So now let's fix it, and to make it visible from both directions, we just need to deactivate the cull mode. This is done here in the second line after we set up the shader type. We add another line and we set the render mode to hull disabled. And now we can see the grass from both directions. Now let's add some transparency to the object. This works just like with the color. There's the variable alpha, to which we only have to assign the alpha color value. So let's set alpha equals color A. And here we go, we have some transparent grass. But wait, something still is wrong. Some blades of grass in the background are rendered in front of the grass in the foreground. To fix this, we just need to add some more render modes. So after the render mode cull disable, we additionally add the render mode depth prepass alpha, which makes sure that everything is rendered in the correct order. But now we lost the transparency. So we add another render mode. This is depth draw opaque, and this render mode only draws the non-transparent parts of the texture. And so, as the final result, we get a nice looking tuft of grass. Okay, and now let's get some movement to the shader. But let me explain how to approach this topic. Remember, we initially created this grass object in Blender. We just put together some planes which consists of vertices. The vertices at the bottom are on the ground. They are at height level 0. And the top vertices are, of course, at a higher level than 0. And now we want to have some movement depending on the height. That means the vertices on the ground, the root of the plant, should not move at all, because it's put in the ground. But the higher the plant is, the more it is shaking to the side. So in the middle of the plant, it should be shaking a little bit, and at the top, it should move a lot to the side. So the algorithm is very easy. For each vertex, we choose a random number, how far the grass is supposed to move to the side, and multiply it with a height factor. Okay, let's have a look at the random number, which tells the grass how it should move sideways. We want a soft and slow movement, so generating new random numbers each frame does not work. This would result in the grass jumping around chaotically. We can use a black and white noise texture. It has some white areas, some black areas, and the color changes smoothly between black and white. So we choose one position in the texture and read the gray value from that position. Let's say white means the grass is tilted to the right, and black means it is tilted to the left. If we now slowly move the selected position in any direction, the gray value slowly changes, and so it slowly changes the angle of the grass. For the grass shader, this means we need to add the noise texture. This is done the same way as we've done it before with the plant texture. So we just write uniform sampler 2D noise texture of type source color. Now we can modify the shader parameters of the grass texture. Here they are. And here is a field noise texture. Choose the option new noise texture 2D, and then you will see the options for the noise texture. Leave the size of the texture as it is, that's okay. But here you'll see the parameter noise. Click on it and select the option new fast noise light. This creates a new texture. Enable the option to make the texture seamless, because when you reach the end of the texture, you don't want the tilting position of the grass to jump at that moment. Then click on the noise texture 2D again to close this category, and you will see there is a generated noise texture. The shader code that we have so far is completely done in the function fragment. The function fragment is for displaying the color on our object. But now we want to modify the vertex position. So we need another function, that is void vertex. No parameters. And here goes the code for the vertex. In this function, we need to find out the position of the vertex because we want to move the vertex to the left or to the right, and we want to utilize the height of the vertex as a factor for the movement. For the position, we need a three-dimensional vector, vector 3, vertex position equals, and the vertex is already passed to this function. It's called vertex, and we need the x, y, z position of this vertex. Then we keep the height of the vertex in an extra field, so float height equals v position y. Okay, what else do we need? We want to move the position in the noise texture with a constant speed in any direction. So the time is one factor that we need. And time is a field that is already present in the vertex function. It is called time. So we set up a float value. Let's call it speed. And it equals field time. Next, we want to get the color value of a specific position in the noise texture. And we already know the color comes in a four-dimensional vector, red, green, blue, and alpha. But the noise texture does not have any transparent areas, so we can ignore the alpha channel. And the noise texture only consists of gray color. That means for each pixel, the red, green, and blue value are the same. And that means we just need to retrieve one value from the color. So it is float noise color equals texture. This is what we've done before to access the color. And we pass the noise texture to the texture function. And then we need to provide the position. When we worked on the color, we passed the UV mapping, but this is not what we are going to do here. We provide some different position, let's say the XZ position of our vertex. So the position XZ. The texture function returns a four-dimensional vector, and as I said before, we just need one value, red, green, or blue. So let's say we choose red. Now we have the gray color value of one specific pixel of the noise texture, and this color value tells us how far the grass shall be tilted sideways. The vertex function is called for every frame, and this calculation always returns the same value because we get the same pixel every time. We still need to shift the noise texture in one direction. Here we have the speed value, which takes the current time, which increases in every frame. Okay, I see. In this case, speed is not the correct name for this value. Let's call it offset instead. But I still want to use a speed parameter, but this one shall be configurable. So let's add another uniform float speed with the default value, let's say 1.0. And now we change the offset parameter, which is time multiplied by the speed. And now to move the noise texture in every frame, we just need to multiply the position of the XZ coordinate here with the offset. And now we are already done with shifting the noise texture because the offset includes the time, and so it is increased in every frame. We multiply the X and Z coordinate, and so it is shifted diagonally. So this noise color value tells us how far the vertex shall be shifted sideways. So let's calculate the new vertex position. And that is the V position multiplied equals the noise color. And next we just need to output the newly calculated vertex position. So vertex equals v position. And here, as our first result, we see our grass moving, not yet as it should be, but we are going to fix it. The first issue, it is moving way too fast, so let's set the speed to a lower value, let's say 0.1, and now we get a soft movement. The second problem is that the grass is not only moving sideways, it also changes the height of the grass. This is not supposed to be. And the problem is here when we calculate the position. The problem here is that we multiply the whole vector with the offset. So we change the position on the x, y, and z axis. So we only multiply the x and the z axis, and now we see the difference. The height does not change anymore, but the grass is moving sideways. The third problem is that we still see the grass moving at the bottom, and to prevent this, we multiply with the height. Okay, now the bottom of the grass isn't moving anymore, but the whole piece of grass now ends up in one single point here. Why is that? Well, we multiply with the height, and at the bottom of the grass the height is 0, so we multiply with 0. To fix this, we need an additive value, so let's add 1.0. So why does this fix the problem? Well, that's easy. We get the vertex position by multiplication. And if we multiply with 1, the value does not change, so we keep the original value of the coordinate here. And since the height is 0, it is a factor of 1. And for the vertices at the top of the grass, the height of course is larger than 0, so multiplying the noise color with the height makes the noise color more affected the larger the height is. Okay, this is looking good so far, but let's add one more configuration option where we can set up how far the grass is moving sideways. Let's call this parameter strength. So uniform float strength equals 1.0, the default value. And now we put the strength into the multiplication as well. So here multiplied by strength. Of course, we don't see any difference because the factor is just 1, which doesn't change anything. But if we set the value to 0.5, now you see it's just moving half the way. So let's change it back to 1.0. All right, that means the shader is done. Now you can edit the material. And as you can see, the speed and the strength have been added to the shader parameters, and you can modify them individually for each material. Okay, now we have one decent looking piece of grass in our landscape, but as I said before, we want to have thousands of them. The piece of grass that we see in our scene was just created as a reference object to set up the material and the shader, so we can get rid of it and delete it. To create thousands of pieces of grass, we want to make use of the MultiMesh instance 3D feature of Godot. This allows us to multiply the piece of grass thousands of times in our landscape, but all copies of the object are calculated just once in one render call, which saves us a lot of resources on our computer. As I just mentioned, this is a built-in feature in Godot. We just need to specify the position, scale, and rotation of each copy of the grass. Doing this can be a little bit annoying, so I created a plugin which helps us in this matter. To install this plugin, just go to the asset lib, type in the name of the plugin, it's called Yamms, click on the plugin, and hit the download button. Yes, I want to install it, and that's it. The plugin is installed. And now you will find in your add-ons directory a subfolder Yamms. This is where the plugin is installed. We still need to enable the plugin. Just go to Project, Project Settings, go to the tab Plugins, and there you will see the plugin Yamms. Just enable it and close the window, and we are done. Now that the plugin is installed, we can spread large amounts of grass throughout the scene. First, we add a multi-scatter object to the scene. Right-click some node in your scene, add child node, and type into the search field multi-scatter and select the multi-scatter node. And there it is. The new created multi-scatter object shows a warning sign. That means something still is missing. The tooltip tells us what to do. We need to set up an area in which the grass shall be placed. The easiest way to do this is to switch to the top-down view in the scene. So just type the button 7 and then you look vertically at the scene. Then select the multi-scatter object. This adds a new toolbar to the scene view. And here you will find some buttons to draw a polygon, which is the area where the grass will be located. Click the Add Point button and draw the polygon area. And so we have set up the area for the grass. In order to put the grass on the ground, we need a collision object underneath the grass area. Here in this example, I already prepared a terrain. And looking sideways, we see that the polygon area is underneath the terrain, but it needs to be above it. So let's move it a little bit upwards. Click the Select Point button so that we don't accidentally draw new polygons, and move it upwards. Looking from top again, we see the polygon area and we see that it's still open here. So click the Close Curve button and the polygon is closed. Great. Now let's have a look at the warning sign again. And the first warning is gone, but the second warning that we need a multi-scatter item still is there. So let's add a multi-scatter item. Right click on the multi-scatter object, add child node. Multi still is written in the search field, and we select the multi-scatter item and add it to the scene. Okay, now the warning sign of the multi-scatter object is gone, so it is set up correctly. But now the multi-scatter item is complaining that there is no multi-mesh set up. So let's fix this. With the multi-scatter item selected in the inspector, we will find a reference to the multi-mesh, which is empty. Click on it, click on New Multi-Mesh, and a new instance will be created. Click at the multi-mesh and set up the options for this multi-mesh instance. Drag and drop the 3D grass object to the field Mesh, set the transform format to 3D, and assign the previously created material in the geometry section to the field material override. Now click at the multi-scatter object again, and as we see, the warning signs are gone, so everything is set up correctly. With the multi-scatter object selected, you can set up the amount. That's the number of pieces of grass that will be spread in the environment. So let's set this to 10,000 because we want to have a lot of grass. And for more convenience, I renamed the multi-scatter item. I just name it grass because I can add more multi-scatter items to the multi-scatter object to add more different pieces of foliage to the environment. Alright, the multi-scatter object is set up correctly, but there's one more thing that needs to be checked. So here's the area in which the grass will be generated, but we want the grass to be attached to the ground. So select the multi-scatter item, the grass object, and make sure that the placement mode is drop on floor. It should be the default, but if there is something different, set it to drop on floor. What it does is it generates a random position of the grass in this area and performs a raycast downwards until it hits the ground, and that's the position where the grass shall be dropped. But to make this working, the object underneath the grass area is required to have a collision object. I already prepared something here. So here is the object, the terrain, and it has a collision shape attached to a static body. And the collision object needs to be set up to a layer. The default layer is layer 1, so I leave it there because I'm using layer 1 as well. But if there is a different layer selected, just click at the multi-scatter and select the different layer here. Then the raycast is performed for a different collision layer. Great! Now all the work is done, and now let's see it all in action. Select the multi-scatter and hit the generate button. And woohoo! There it is. There's a lot of grass moving in the wind. Alright, this already looks absolutely awesome, but we still need to improve several things. One thing is, there's no grass at the roof of the house. Yeah, but it shouldn't be there, so it is okay. Well, kind of. The house does not have a collision shape in my example, so the grass falls through it and ends up on the ground inside the house. And furthermore, there are other areas like pathways or rocky areas where no grass is supposed to be. Let's fix that. To do so, right-click the multi-scatter, add child node, and choose the multi-scatter exclude. Hit the key 7 to go to the top view and draw some polygons for the area which shall be excluded. So let's go here, exclude the area around the house and some of the pathways. So that should do it. Close the polygon. Select the multi-scatter again and hit the generate button. And there we go. The area of the exclude area is excluded and no grass is inside that area. Alright, what else can we do? A closer look at the grass reveals that every piece of grass looks exactly the same. So let's add some variation to it. The best idea here is to enable the random rotation for the grass. So select the grass object, open the category random rotation and enable the rotation. Set the max degrees for the Z value to 360. Select the multi-scatter and generate again. And now each piece of grass is randomly rotated. Next, let's do the same with the size of the grass. Select the grass, open the category random scale and enable the random scale and set a lower value to each axis. Let's say 0.5. Then select the multi-scatter again and hit the generate button, and now you have randomly scaled pieces of grass. Oh, and by the way, the parameter name max scale is a bit misleading. Actually, it is minimum scale. That means the multi-scatter item scales randomly between the value you entered up to 1.0. Alright, and there it is. Awesome looking grass. And I hope you enjoyed the video. Thank you for watching. Hope to see you next time. Bye!